So before we get started, let's see what is involved in setting up an iSCSI target and initiator. So in iSCSI is an extension to the SCSI protocol. Traditional SCSI uses a long cable and a SCSI command descriptor block command to attach to SCSI devices. In iSCSI we are using the same CDB commands but encapsulated in IP packets that are sent over a network. And in iSCSI the SCSI devices are emulated by using a storage backend and presenting it on the network using iSCSI targets. So what you will be doing is you will be creating some storage, which can be a partition or a logical volume, and you will share them over the network using the iSCSI target. In iSCSI you also need a network. That can be an Ethernet infrastructure. These can be as fast as fiber channel structures, which is another SAN solution. And that makes iSCSI an enterprise-ready choice to create a SAN. So in iSCSI, what we've got is on the bottom a SAN. On the SAN we have a process which is the iSCSI target. And the iSCSI target gives access to the storage backend. And then there's a server that wants to connect to the SAN. In order to do that, the server runs the iSCSI initiator, which is also a process that you will be starting on your server. And from the iSCSI initiator, you need to do a discovery. The discovery is going to talk to the SAN to find out what exactly is offered. And once the iSCSI devices have been discovered, the iSCSI initiator can do a login to the devices. So different components are involved. First, there's the target on the SAN that gives access to the storage backends. These storage backends are something that you need to set up yourself as well, as we will see in the demo that will follow this presentation. The backend can be a complete disk. It can be a dedicated partition. It can be a logical volume. It can even be a file, as long as it's a big empty file that you can export as a storage device. So in iSCSI we need servers to connect to these using the iSCSI initiator. And after successful connection, the connected server will see the newly added storage devices. On the iSCSI initiator you can check that in the proc partitions file, which gives you an overview of all partition and storage devices that are currently known to a server, or by using the RHCE tool, which is not installed by default, by the way, but it's available in the repositories, so it's easy to use it. Before starting your work with iSCSI, it's good to have a good notion of the terminology that is used. So first there's the IQN, which is the iSCSI qualified name. That's a unique name that is used for identifying targets as well as initiators. It is important to set the IQN because it can be used in security. Then there's the initiator. The initiator is the iSCSI client that is identified by its IQN. We have the target, which is a service on an iSCSI server, that is the SAN that gives access to the backend storage devices. And you can work with ACLs. ACLs are access control lists that are based on the node's IQNs. And then there's the notion of a portal. A portal is the IP address and port that the target or initiator uses to establish connections. It is also referred to as a node. We will see this node part when using with the iSCSI ADM command on the iSCSI initiator. There's discovery, which is the process where an initiator finds the targets that are configured on a portal. So you can have more than one portal on one server, you can have more than one target on one portal. And there's the LUN, which is the logical unit, the block devices that are shared through the target. Then there's the process of logging in. Logging in is the authentication that gives the initiator access to LUNs. And there is TPG, which is the target portal group, which is a collection of IP addresses and TCP ports to which a specific iSCSI target will listen. It is important that you know this terminology even before going to the exam, because the tool that you'll be using for setting up iSCSI uses this terminology. And if you don't know this terminology, well, you don't know what the tool is expecting from you. So after connecting from the iSCSI initiator to the target, the iSCSI initiator will see added block devices as local devices, such as dev-SDB, dev-SDC, and so on. And if a LUN is exposed to multiple servers will have access to the device after connecting to the LUN. Which is like if you connect a hard disk to different servers, at the same time. That is kind of cool, but also kind of dangerous. So if you want to create a configuration like that, you normally would need clustering to provide access to the device, just to make sure that it can never happen that two servers are writing to the same file system at the same time. Because if you try to do that on an XFS or an ext4 file system, well, it's not really made to do that. As an alternative, you could also consider using a shared file system like GFS2. In GFS2, the file system cache is shared between the nodes, which means that all nodes writing to the file system are aware of what the other node is doing. But both clustering and GFS are not part of the RHCE objectives, so we won't talk about that in here.